Hello everyone, I warmly welcome you to CS Digital Classes. In this lecture, we are going to discussing about order of an element under addition modulo. So let's see the question first of all. Find the order of the group and order of the each element in the group z suffix 12 and z suffix 10 under addition modulo 12 and 10. And again, he is asking another question. What do you see the relation between them? Okay. So after getting the solutions of end of the problem, what is the relation between the order of the group and order of the element? We have to conclude that. Okay. In the recent examination, the questions asking in this format: find the order of an group and order of an each element, and what is the relation between them. Okay. So one of the important question. So we can start the solution. Given z suffix 12 is the group of integers under addition modulo 12 under addition modulo 12. So first of all, I am deriving the solution for the addition modulo 12. Later on we can discuss about addition modulo 10. So, and before going to start the solution, you need to get the conclusion that the set of integers under addition modulo small n satisfies group. Okay, so you know very well the set of integers under addition modulo small n. So that is z suffix n is equal to 0, 1, 2, 3 up to so on n minus 1. Okay, so for n greater than or is equal to 1 is a group under addition modulo small n. Now here we have the group capital G is equal to z suffix 12. Okay, by using the under addition modulo 12, we have to find out the order of this group and order of each and every element of this group. First of all, order of the Z12, order of the Z12, order of the group Z12. Okay, as we discussed in the introduction classes, order of the Z12 is nothing but the total number of the elements. Total number of the elements gives that order of the group. Okay, now I am writing the total number of the element in this set. Z suffix 12 is equal to, okay, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, 12 minus 1. N minus 1 is the last element in this set. Okay, n minus 1 is 12 minus 1 is equal to 11. 11 is the last element. If you count them, okay, so in Z12, okay, including 0, if you count them, you will get 12 elements. So therefore, 12 order of Z12, okay, mod Z12 is equal to 12 because there are 12 number of elements. So this is the order of the group Z12. Now we are going to find out the each and every element. Here we have 0, 1, 2, 3 up to so on 11. So now we have to find out the order of the element under addition modulo. So now see here, in addition, I am writing the general formula for the order of an element. In addition, the formula for order of addition, okay, the formula for order of an element is n into a is equal to 0. N into a is equal to 0, where small a belongs to z suffix 12, okay, and n belongs to positive integers. N belongs to positive integer. Here n is a positive integer and small a is equal to z suffix 12. So now, so I am taking z suffix 12 is equal to, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 11. Okay, so this is the group of z suffix 12. So now we have to find out the order of each and every element. So first of all, for 0, for small a is equal to 0. For small a is equal to 0. So I am writing n belongs to z plus So therefore 1 into 0. 1 into 0 is equal to 0. Next 2 into 0 is equal to 0 up to so on. In this method, if you follow that, the last number 11 into 0 is equal to 0. For each and every element, if you take for each and every value n is equal to 1, 2, 3 up to so on 11. Okay. So for a will be fixed. Okay. The value of a does not change in this process. So therefore, you will get 0. Here 0 is the, since you know very well, 0 is the addition identity. Okay. 0 is the addition identity. 0 is the addition identity. So therefore, in the RHS part we have 0. So therefore, the least positive integer where you get the addition identity is the order of the given element. Okay. So now here each and every case we got the resultant value is equal to 0. So now the least positive integer out of 1, 2, 3 up to so on 11 numbers, the least positive number is 1. So therefore order of 0 is 1. Order of 0 is 1. So therefore we can write in the mathematical mod 0 is equal to 1. Order of 0 is equal to 1. That is the order of the first element in the Z12. Next, the second one, for A is equal to 1. For A is equal to 1. I am writing the formula n into A is equal to 0, where A belongs to Z suffix 12 and n is a positive integer. Now substitute the formula. Now substitute the values. For n is equal to 1. 1 into 1 is equal to 1 only. Okay. This one less than 12. Okay. We are applying that addition modulo here. Less than 12. We cannot divide that 1 by 12. So therefore 1 is the remainder. Next, n is equal to 2. 2 into 1. Okay. So a value fixed. A value does not change. We are just changing the values of small n. So 2 into 1 is nothing but you have to write this value in this format. Whenever you have addition modulo, 2 into 1 is equal to 1 addition modulo 12 1. Okay, 1 plus addition modulo 12 plus 1. 1 plus 1 2. 2 by 12. Again you will get the 2 is the remainder because 2 does not divide by 12. Next to 3 into 1. 3 into 1 is equal to 1 addition modulo 12 plus 1 addition modulo 12 plus 1. So therefore, here also you will get 3 by 12. So again you will get 3. So we have to do this process until you get the remainder is equal to 0 because 0 is the addition identity. So next 4 into 1. 4 into 1. Okay. 1 plus 12. 1 plus 12. 1 plus 12. 1 plus that is equal to 4 by 12. Then you will get the 4. If you proceed, if you continue in this format. Okay. So whenever n is equal to 12. Okay. So n is equal to 12 and a is equal to 1. You will get that 1 addition modulo 12 plus 1 addition modulo 12 plus 1 addition modulo 12 up to so on. Addition modulo 12 1 is equal to 12. Okay. 12 into 1 is equal to 12. But this product, okay, in the formula, I clearly mentioned that formula is n into a is equal to 0. That is the original formula. That formula we are representing in the addition modulo format. 12 into 1 is nothing but you have to add 1 12 times. So therefore 12 into 1 is equal to 12. 12 by 12 is equal to remainder is the 0. So therefore you have to stop the process here only. So we got the addition identity 0. So therefore next no need to go through the 13 value. Okay, 13 into 1. So no need to go to n is equal to 13. So therefore you have to terminate the process there only. So therefore order of 1 is 12. Order of 1 is 12. So therefore in mathematically mod 1 is equal to 12. Mod 1 is equal to 12 is the order of 1. Now for a is equal to 2. Okay, the third element in the group a is equal to 2. Now take the formula. So n is equal to 1, a is equal to 2. 1 into 2 you will get 2. 2 is less than 12. Next to 2 into 2 4. Okay, that means 2 under addition modulo 2 plus 2. Okay, you have to write down 2 plus 2 is 4. 4 by 12 again you will get 4 only. Next 3 into 2. 3 into 2 is nothing but 2 plus addition modulo 12, 2 plus addition modulo 12, 2. Okay, 2 plus 2 4, 4 plus 2 6, 6 by 12. You will get 6 is the remainder, but we need to get that addition identity 0. So therefore, in this format, if you proceed 4 into 2, 8. Okay, so next 5 into 2, 10. Next 6 into 2. 6 into 2 is nothing but 12. Okay, so 12 by 12 is equal to 0. 6 into 2 is 12. 12 by 12 is equal to remainder 0. I am writing here the remainder value. That remainder is the addition identity. So therefore, so we have to stop the process there only. Okay, so therefore order of 2 is at the value 6. Okay, so is 6. Therefore order of 2 is equal to 6. In this format, for the next number, for a is equal to 3. For a is equal to 3, similarly we are writing 1 into 3 is equal to 3. Okay, so 2 into 3, 6. 3 into 3, 9. Okay, 3 into 4, 12. For this number, I am writing 3 under addition modulo 12. Okay, 3 under addition modulo 12. 3 under addition modulo 12 and 3, that is equal to 3 plus 3 6 and this 3 plus 3 9 and this 3 plus 3, okay, 12. 12 by 12 you will get the remainder is equal to 0. Okay, so therefore after getting the remainder is equal to 0, order of 3 is at small n is equal to, so therefore order of 3 is 4. So therefore mod 3 is equal to 4. In the next, for a is equal to 4, I am writing that 1 into 4 is equal to 4, 2 into 4, 8, 3 into 4, 12. Okay, so this 12, if you divide by 12, then you will get the remainder 0. So therefore order of 4 is 3. Okay, for n is equal to 3, you got the remainder is equal to 0. That 0 is the identity addition. So therefore that implies you can write mod 4 is equal to 3. In the next sixth one, so for a is equal to 5. For a is equal to 5, so therefore 1 into 5 you will get 5. 5 is less than 12, and 2 into 5 is equal to 10. 3 into 5 is equal to 15. Okay, 4 into 5 is equal to 20. Next 5 into 5 is equal to 25. Next 6 into 5 is equal to 30. Okay, so 7 into 5, 35. 8 into 5 is equal to 40. So 9 into 5 is equal to 45. 10 into 5 is equal to 50. 11 into 5 is equal to 55. So 12 into 5 is equal to 60. Okay, so next, if you proceed in this format, you can get that after getting 12 into 5 is equal to 60. If you divide this 60 by 12, 12 1 the 12 5 is 60. So therefore 0 is the remainder. So therefore order of 5 is n is equal to 12. Okay, at the value of 12 we got that remainder value 0. So therefore order of 5 is equal to 12. So therefore mod 5 is equal to 12. Order of 5, mod 5 is equal to 12. Next, the seventh value, for a is equal to 6. For a is equal to 6. Now for order of a is equal to 6. So here if you start with 1 into 6, 6, and next 2 into 6, 12. 12 by 12 is equal to 0. So therefore order of 6 is equal to 2. Similarly, order of a, okay, order of 7 is equal to, so 12 into 7, 84. 84 by 12 is equal to 0. Therefore order of 7 is equal to 12. Okay, next number, a is equal to 8. Order of 8, 3 into 8 is equal to 24 by 12, that is equal to 0. Therefore order of 8 is equal to 3. Now for a is equal to 9, order of 9 is equal to, we got 4. And for a is equal to 10, order of 10 is equal to 6. And for a is equal to 11, order of 11 is equal to 12. Okay, so now we got we find that order of all the elements in the Z12. If you observe carefully, okay, so order of Z suffix 12 is equal to 12, and order of each and every element, order of 0, okay. So order of 0 is equal to 1, and order of 1, order of 5, and order of 7, and order of 11 is equal to 12. Next to order of 2 is equal to, order of 10 is equal to 6, and order of 3 is equal to, order of 9 is equal to 4, and order of 4 is equal to, order of 8 is equal to 3, and order of 6 is equal to 2. Okay, so this is the order of the group, and these are the orders of the elements in the group. So in the examination, what is asking that, what is the relation between order of the group and order of the elements? If you observe carefully, order of the group is 12, and order of the elements of the group is 1, 12, 6, 4, 3, and 2. Here we can conclude that here we can conclude that the relation between order of the group and order of the each element in Z12 is, if you observe carefully, order of each element in Z12 divides the order of the group. Okay, so that is Z suffix 12. Order of the group is 12. This 12 is divided by 1, 12, 6, 3, and 2. These denominator values are the order of the each and every element. So therefore, order of the each and every element divides the order of the group. This is the relation we can observe after the solving the problem. In this method, in the examination, they are asking the what is the relation after getting the final result. Okay, so you have to give the conclusion in this format. So this is the solution for this order of the Z suffix 12 under addition modulo 12. If you take Z suffix 10, okay, so you have to solve the same problem in this format only. Okay, you know the Z suffix group is equal to 0, 1, 2 up to so on 9. Okay, so mod Z suffix 10 is equal to 10, and after finding the order of the group, and you have to find out the order of the each and every element in Z suffix 10. After getting the orders, you have to compare the relation between. Okay, there also order of the group is divided by the order of the each and every element. That is the conclusion you have to mention in the examination. Okay, so in this format you have to write the solution of this problem. This is the one of the important problem, okay, oftenly asking in the examination. I hope you understood this problem very well. In the next lecture we are coming with another new topic. Okay, so practice well, prepare well. So thank you.